Let's go.
You're listening to Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
Podcast listeners, Al Martin here. Welcome back. We always appreciate you listening. Today, I have as a guest, Alex Watson. The topic in the category we're going to discuss today is synthetic data, security, AI, startup leadership, everything in between, go wherever we need to go. He is, what are you? You the CEO of Gretel? Is that right?
I'm the co-founder and chief product officer.
CPO, like it.
Yeah, thanks for inviting me on Making Data Simple.
Yeah, thank you. So let me say a little bit and then I'll let you introduce yourself. Gretel's a privacy startup that enables developers, researchers, and scientists to quickly create safe versions of data for use in pre-production environments and machine learning workloads, which then are shareable across teams and organizations. These are tools that address the data privacy bottleneck, and this bottleneck that typically stifles innovation across multiple industries, for example. It allows you to equip builders everywhere with the ability to create quality data sets that ultimately scale. In short, I would say synthetic data levels the playing field for everyone. That's the motto, I think, here. With that, how did I do, Alex? Did I do all right?
I think that's a fantastic introduction.
And I know that, if you allow me to say, recently closed your Series A funding by Gretel.ai, and I know you've got other investors with the GitHub investors, et cetera. So I think you're starting off pretty hot. If you wouldn't mind, go ahead and talk to me about a little bit of experience, what led you to Gretel, and kind of where your mindset is in terms of the business plan that you currently have at Gretel.
Well, I love it. I'm happy to start with a quick background here. This is my third startup, which I never thought that I would be that person that came to 3 different startups, but really, just thrilled with the opportunity and some of the problems they're solving with Gretel, and would love to dive in on it today, and hoping to really knock it out of the park this time. So very excited. Talking on just really fast, kind of background. Actually started my career out of college, computer science, started my career at the NSA. Had an incredible experience there. I came there right after September 11th. So I started in 2002. And got to work on problems that I think really kind of even influence how I look at things today, where we were working on, huge big data problems, and also got, kind of leading to what I worked on after I left the NSA, kind of experienced kind of firsthand some of the challenges that businesses are up against when it comes to protecting their data and their infrastructure and their intellectual property from a really determined and capable attacker. And really, when I left NSA and got an opportunity to found my first company, which was a startup in the cybersecurity space called Harvest.ai, it was around how can we use machine learning and how we can use the best of breed technologies out there to find those risks that would come after your business in a way that didn't impact normal operations. It enabled people to share data.
What happened to Harvest.ai?
We had an incredible run, actually. So we did a Series Seed. We built for about 2 years, and our focus was on helping companies protect their SaaS environments. So we were one of the first companies out there with a protection solution for Google Suite, Office 365, Salesforce, those places where companies wanted to start using SaaS technologies, but they didn't have protection or visibility into what was happening. So we had a combination of natural language processing to identify important information, and then we had behavioral analytics that would look at how that sensitive data was being accessed and really only step in when something scary happened. As I said, we built for about 2 years. We were going out for our Series A, and we got approached by AWS around acquisition. What an incredible opportunity. I think at the time, AWS had been interested in offering security services to their customers to help them protect their AWS environment for a couple years. And they saw a really nice fit with the technology we were building and their kind of philosophy and approach. So we got to come in. I was a general manager for 4 years there for AWS Macie, which is a service that customers use to identify and protect important information in the cloud using NLP. I think a lot of the lessons that I learned there, both, kind of seeing that incredible access to data that we had, building a service inside the walls at AWS, and how that can influence product decisions and make you so smart, really, in understanding your customers. And then also seeing those challenges that many of our customers had, enabling that same level of access to data inside of their business and how limiting that can be.
So what time frame was this, the Harvest.ai piece? And then when did it start? When did it end?
Yeah, so we started building Harvest.ai in 2013.
Yep.
We were acquired by AWS in early 2016. I stayed there as a GM through 2019. Got AWS Macy launched, grew it into actually one of the top services that we have at AWS, through a series of, I think fantastic conversations and relationships that we had with customers where they would talk to us about some of the challenges they had building with data or enabling data access or understanding where that is. Both built a great service and then influenced a lot of the thinking for building Gretel today.
Say a little bit more about Harvest AI, though. When you talk about protecting SaaS environment using NLP, these security services, how does that play out? Give us keep it simple, yet you make it meaningful in terms of what kind of protection we're talking here.
Sure. The theory that we had with Harvest AI was that when modern attacks are coming in, that the existing mechanisms that you would use to detect risks on your data wouldn't be sufficient. I think it's pretty well understood that account compromise can happen, password compromise can happen. And what that results in is, I think that classic example of, a person who normally logs in from Baltimore, attempting to log in from some foreign country across the world at the same time. From my experience at NSA and also what I was kind of seeing happening in the ecosystem, I knew that wasn't sufficient. Like a really determined attacker that's coming in would look just like the types of, they'd be using a compromised account. Perhaps they got it through spear phishing, but it would look just like that user coming in. You'd be logging in from the same location. Really fundamentally what happens and what many security practitioners look for is a change in the type of data you're accessing. Classic example would be someone who typically deals with finance paperwork and things like that, all of a sudden looking into system uptime schedules and data center migration plans and things like that. So our idea here was saying, can we replicate that same process that we know the best security researchers or best security operations specialists do, where you start looking at this account might be compromised. What indications do we have that they're accessing types of data that are risky to our business? And can we automate that with machine learning?
So let me see if I can restate that back to you. Essentially, you're saying, look, we're looking for anomalies. They're accessing one type of data, and all of a sudden they start looking at credit card info. I don't know, whatever.
Yeah.
You say, hey, there's something wrong. But how does NLP come to play into that?
The NLP component, it's really kind of the most important kind of leg in this entire understanding. And it's really understanding like what is important data to the business versus what is just a public slick sheet that's shared for your product. And so often that responsibility falls to the security practitioner to dive in and try to understand that themselves. So our question was, can we use NLP to find out what's unique about a business? And really, the goal here is empowerment. It's allowing businesses to use Google Suite, Office 365, like these really cool capabilities, help their employees collaborate better, and really only step in when you see risky access to important data. So in this case, NLP, we were able to use that to help identify unique or important data, as you mentioned earlier, credit card information, PII, things like that across your business.
Nice. So then you go to Amazon, you stay there till 2019, and then...
I had an opportunity to found Gretel with a few of my, I'd say most respected colleagues that I've worked with and also extremely close friends. And
so you stole everybody from Amazon.
I wouldn't go that far. I waited 18 months.
Well, you gave us some time. That's fine. That's good. That's all good now.
I mean, really kind of tackle a problem that we saw kind of emerging in the market, and the one that also hits us really personally, at home every day. And what that problem is centered around is the types of data that are out there. As you know, we all have smart devices in our homes. We all value, our Nest cameras and our, Ring doorbells and things like that. But the truth is that these services around us are collecting more and more sensitive information every day. Those benefit our lives. It's really important to us as consumers, to me as a parent with children, that types of information that gets collected is used in a way that maintains our privacy, and really kind of looks out for our best interest as a consumer. What we saw was that many of these companies, these tools don't exist. How do I do privacy engineering? How do I ensure that I can enable data access in my business? That gets blocked a lot of times based on the sensitivity of the data that you really kind of limits that you collect as a company. It limits it to a small group of people that have been certified to work with that. And the question is there ways that you can enable innovation? Can you enable more people within a business to test ideas and build better products while maintaining the privacy of the data that's collected on? And if that's possible, what can we unlock? And that's really the thesis for Gretel. We're starting out with a set of tools. We use something called synthetic data, where we're building really incredible machine learning driven synthetic data platform that can create an artificial version of any data set, of any structure. It can be a database, it can be a CSV file, or, for data scientists, they love working with pandas data frames. Can we build an artificial version of that has the same insights and the same distributions as the original data without using real customer names, real customer addresses, or data that could be tied back to that customer?
So I got several questions. Well, let's just start at the top. In terms of privacy engineering, you say, look, there's not enough companies out there. Obviously, given the amounts of ransomware we're seeing, there's not enough companies out there. How can that be the case at the same time with all the stuff that's going on in the industry right now, the break-ins, the ransomware, the stuff from Russia, all this stuff? How can we not have enough focus? Is it a knowledge thing? What's the problem?
I think that some of the challenges that we've seen in this space, I would separate security and privacy in this context and say a couple things. One, with the ransomware challenges that you see today, here you see a really kind of determined group of attackers that are exposing a vulnerability that exists where many businesses don't have the policies and the frameworks and the kind of security mechanisms in place to protect their data. And they only need to find one vulnerability, right? And that one vulnerability they can expand upon. Look at the healthcare systems, for example, right? Like where hospitals a lot of times run appliances that are incredibly expensive, an MRI machine that might have a version of Windows 95 running on it, and for them to upgrade that operating system, they would have to buy a whole new MRI machine, which just isn't cost effective. Where we see ransomware challenges in, for example, the healthcare world, it's around exploiting those vulnerabilities that attackers know exist and then expanding from there. With some basic security mechanisms and improvements, I think there's a lot of room to protect against ransomware. And we're starting to see, the whole kind of world kind of investing in how do we build that basic, protection mechanisms, backup mechanisms, things like that really will help protect against ransomware. But that's a case where the whole industry needs to evolve really quickly. Data privacy, as a separate component here, the second part of the discussion being that like super sensitive data you have inside your business, which often gets replicated and gets breached. Like, why aren't there better mechanisms for protecting privacy? That's a really complicated question. An answer I've seen talking to customers that we work with is that the pace of innovation around software is so fast. We use new tools and new technologies all the time to solve problems. As a business, many of the customers we talk to believe in developer empowerment, and they want to tell developers, use the best tool you can to solve this problem, which leads to innovation. It leads to happy developers. It leads to really great services for your customers. It can also be hard to build protections around it. And historically, I think a lot of data privacy tools have been all or nothing. And the idea of like, give us all your data and we'll protect it, and we'll give you a couple mechanisms you can use to access it. What we hear from developers is that boxes them in to a certain solution with a certain set of capabilities that doesn't allow them to innovate. So when we started building Gretel, one of the first things that we had is, how do we build privacy engineering and make this possible for a developer without being prescriptive about what tools they use? So we integrate directly as APIs. We integrate directly with SDKs, really meeting our developers where they're developing, using the types of tools and databases or warehouses and technologies they want. I think is one of the things that we're doing pretty uniquely that is enabling us to develop and to deploy within large businesses really quickly.
Look, I think you're wise to separate security from privacy because they're different, to your point. Quickly back to security real quick.
Sure.
Does the tech exist today? Do you believe? I mean, is it complete? Is it comprehensive to avoid some of these ransomware issues? Or is it kind of the legacy system situation? The MRI is a great example. I mean, we just can't afford to redo this system. And so we go with legacy knowing that there's risk out there. And is that where most of the attacks are happening?
The technology exists today to protect against ransomware attacks. What I often kind of encourage the different customers that we talk to or people asking these questions is to say, use the best of breed technologies out there for SaaS applications, for example, the Google Suites of the world, the Office 365s that exist out there, Dropbox, Salesforce, things like that. When you pair that with really strong authentication technology, whether you're using an Okta or using a Duo or using any form of two-factor. So essentially, two-factor authentication, which verifies your password and your login with something that you own, whether it is a authenticator app or it's a YubiKey two-factor device or even just a text message to your phone. These types of things give you a really good start at protecting your account, which is what ends up being compromised, which leads to the ransomware problems. A second thing that I would say along the same lines is developing, and this takes a lot of effort for companies to do. But when you kind of start building applications in a really modern way in the cloud, you get some really great protection mechanisms, such like, for example, automated backups and things like that you can do that would protect even in the event you are compromised. You can create a one-way transfer backup to a daily backup, and at worst case, you as a hospital are losing a day worth of patient records. You're not losing years worth of patient records.
I think, that's interesting. You mentioned the one-way transfer backup. I'm a data guy. This is making data simple, even though we go everywhere. We're in security today. But I think there's so many backups. Somebody was telling me the other day, we were looking at some statistics, and I'm going to get this wrong. So anybody listening, please do not take, but it was something like, if you get hacked, the average backup you have to go back to, in other words, before you notice, it's like something like 65 days or something.
Yeah.
It's like you lose almost a quarter's worth of work, at least 2 months anyway. It was somewhere, I want to say it was 65. So you mentioning the one-way transfer is an important aspect that most don't consider. That's pretty huge.
Yeah. The one-way transfer, prevents someone from going in and compromising your backups, which is, one of as ransomware techniques become more targeted, a really common technique that you see is that the attackers compromise your infrastructure and then they compromise your backups. So to your point, that compromise may happen for a while before you detect it. So one of the kind of useful techniques is validating that data that's going into your backups. Like, does it still match the schema? Does it still match the shape that you're expecting it to do? Or is it possible, like you just mentioned, that you're backing up a database that's already been compromised? So I think there are a couple important stages there. But the one-way backup and really kind of preventing the possibility of that database being corrupted is a really important step for protection. And then the second one too is making sure that things that you are backing up are the information you're expecting.
Yeah, good advice. All right, so now I transition back to privacy. I can see your point in terms of, well, let me kind of state, and I'd like you to expand on this. As we're moving as fast as we are moving, businesses that are trying to transform and get to where they need to be and beat the competition, you got to be moving fast. That means you're democratizing data as fast as possible as well. You're going to have gaps in governance that you need to continually bridge. Meanwhile, to your point, you got the developer that's saying, hey, just leave me alone. Don't put all these processes in place if you want me to innovate at the pace that you want me to. Is that, you think, what's causing some of the internal privacy? Is that number one on the list or not so much?
I think that is right up there. I would probably categorize it as two challenges that businesses have for enabling data access. One is technology, right? Do you have technology that makes it safe for you to share that really sensitive data you're collecting? Number two, and equally important, if not more important, is the cultural challenge, right? Do you trust people outside your immediate sphere? And how do you build that level of trust? We use, I think, a kind of an interesting parallel that we think about quite a bit, actually, is what GitHub was able to do over the past 10 years with the introduction of the pull request. So, rewind 10 years ago and ask the same question about software, where it was at times unfathomable to think that you would bring in software that was developed open source by some person you didn't know and use it or build upon that. But what GitHub did is they made that a social experiment. They got over that cultural challenge of building with software where you didn't write all the software yourself by introducing a trust and a social component with GitHub. So you see people's face as developers. You can see what they've contributed to in the past. You can see the quality of their code. Also, you can enable collaboration through this idea of a pull request, where you can make a change, you can suggest that change, people can review it and incorporate it. Some of those same challenges exist with data, where you may not know the persons that are going to access this data or how they're going to use it. So the question is, from a technology perspective, how do you make it safe so you're protecting the identities of the customers or the sensitive data that this is based upon? And then how do you build that level of trust across your business that enables you to share that with other people in your business? And over time, if we have provable guarantees around privacy, why not open source, that artificial, de-identified data in a way that other businesses can leverage it and use it?
Yeah, great information, man. I have to tell you at IBM, I think here we agree with you on almost all your sentiment. We're really pushing open for all the reasons you mentioned earlier. In terms of, I actually believe that sticking to one like governance strategy or whatever can actually make you more vulnerable than being open. That's why we drive hybrid solutions across hybrid cloud, et cetera. Going back to Gretel, what does Gretel stand for? What's the meaning of Gretel?
It's a play off of Hansel and Gretel,
Okay.
and the breadcrumbs we leave behind. And we're kind of likening it to, leaving our lives. The more and more the data that gets collected about us, we leave these kind of digital breadcrumbs that identify us and the path that we're on. While we're building tools for developers and for companies to enable safe data access, the goal here is to protect the privacy of the individual consumers that this data is based on. And that's really, that Gretel is a nod to that.
Nice. What you just described to me, data breadcrumbs, is like blockchain. You don't use any blockchain, do you?
We don't. And I think blockchain is a fascinating technology that has just a million interesting applications for it. The underlying technology we use here is a neural network. So deep neural network, very similar if you've seen the work that OpenAI is doing around what they call it GPT, but these are language models that can write tweets or they can write articles, very similar to, I think that's, some of the popular use cases. It's using machine learning to train on a few samples and then write, for example, a article that is completely artificially generated.
Right.
Our approach is very similar, but we do it for the types of data, structured data that you might have inside a database or a data warehouse.
You started this company from square one, or did you get pulled in to be the CPO, or how did that work?
I started the company. So myself and my co-founder, John Myers, CTO, he had a company, security company as well, that was acquired by NetScout, Arbor Networks. He was building massive de-identification systems that allowed them to learn from their data as well, and realized he was spending just as much time building the privacy framework as the actual application itself. So we left 2 years ago. We prototyped initial APIs and SDKs and open sourced our synthetic data platform, talked to a bunch of customers, and went out and raised money that we could use to build a core team and then build out what we launched last August as an open beta for our software.
Nice. Is that where you're in right now, is open beta?
Yeah, we just last week we launched beta 2. So essentially what we've done is we've evolved from, we like to call it Lego blocks, but software development kits that you could use to train a synthetic model to generate synthetic data for you, to a pure API-based approach, which we just launched 2 weeks ago. And it's as simple as from our cloud console or from a command line or from an SDK, 2 lines of code, or just an entirely console-driven experience. You can take your data set, drag it in, have our machine learning train models in the background for you, and give you an artificial data set that you can start working with. So really trying to lower the bar and make synthetic data available to more people.
Why synthetic data? Why can't I just use regular data? It's like our producer said, hey, you need to talk to this guy. He's like bridging the frog data in Jurassic Park. I said, I'm not quite sure that that's what he's doing, Kate.
Great analogy. There's actually, and I think both of these applications for synthetic data would apply to Jurassic Park pretty well. I think the first one, it's been proven that even with traditional de-identification, do the best job possible from the best data science team possible to de-identify a data set and then open source it, that it can still be linked to, these are called re-identification or linkage attacks. They can still be linked to other data sets that would compromise privacy. So let me give you kind of a classic example of this. Netflix had something called the Netflix Prize Challenge, and this was a competition they hosted a couple years ago. They open sourced 100 million movie reviews from their internal database. And these were identified. It was just a user ID and a movie number and a rating and a date. So it seems very simple and it seems very, anonymized for all of their subscribers. And they had a competition to say, if you can beat our recommendation algorithm based on this data, we'll pay this team $1 million. So they had a lot of interest and a lot of companies started doing this. Some researchers realized that you could take just that combination of movie ID and user ID and date became identifying enough that you could compare it with IMDb ratings and very quickly uncover users and figure out who these people were and what types of movies they were rating. And it was such a serious thing that required Netflix to pull down the challenge and kind of move away. So our approach here with synthetic data is that we will create a completely artificial data set. None of those records get recreated. So they can't get joined with another database that might exist. But the idea is that the data set itself still has the same kind of insights and distributions as the original data.
I mean, I think the worry here is that you go to synthetic data, you're going to lose some element of the data and the integrity of the data that makes it less value than the real data itself.
Mm-hmm.
Tell me how that's not true.
The answer there, I think that sentiment is definitely right. You're creating an artificial version of a data set. So how can it be smarter than the data set? There's two ways to look at this. One, in many cases, if you're just training on that data, it's not. It will have 90 to 95%, as we've been able to test, of the utility of that original data set. The difference is, and this is where we see kind of a opportunity cost within businesses, right? The difference is you as a developer might have an idea or data scientist have an idea and you want to build a new feature or you want to test a new idea. What if you could get granted access to the synthetic data set 5 minutes after you had your idea versus waiting for weeks to go through compliance and get approvals and get access requests to data sets? So that's the first one, is kind of the innovation opportunity cost as a really neat thing. The second, and really this is where you can, and this is kind of getting to your Jurassic Park scenario, like where you can build a better synthetic data set than the original data it was based on, is that you might have enough of the data, but you never have enough of the right data. In the fraud examples, you might have a handful of possible, fraudulent examples and then millions of non-fraudulent examples. So the question is, if you train an algorithm on that, how do you get it as good as possible detecting fraudulent examples? And the neat thing that we can do with synthetic data is we can say, generate more samples that look like this. So you can build a better data set to train your machine learning.
But okay, so I got it. But I guess then the follow-on question is, here's what I hear you say: you never have enough of the right data. That's what I thought I heard you say. So you need to, in some cases, expand the data set so you can, get better answers through machine learning or whatever. But don't you inherently increase the opportunity for bias in doing something like that?
That's something, yeah, I view synthetic data as a tool to improve the quality of your data. Looking at biases you might introduce is a really important thing, and one we spend a lot of time on. I'll share some research we did early, and really this kind of bias reduction came from early conversations with customers. We were working with University of California, Irvine on synthesizing really sensitive healthcare data sets to see if they could make it more accessible inside of their business. And one of the challenges they came out with was they were saying there's a heart disease detection data set that they've actually open sourced. It's available. It's one of the top data sets on these data set competition platform called Kaggle. And the challenge they had was they had nearly a 2-to-1 ratio of males to females in that data set. And when people would train an algorithm on that data set, the algorithm, by definition, tries to maximize its ability to predict whether you have heart disease or not. And it would get really good at detecting male heart disease and it'd be terrible at detecting female heart disease. Right. So the question that they had was saying, can we use your same synthetic library and use it to boost the representation, in this case, of female records inside of this data set? And if we do that, will it improve our ability to detect heart disease, both for female class, but then also across the entire data set? So this is one, as you're saying, you got to be careful when you do this about what types of new biases you introduce. But the testing we've done since then, and we open sourced and blogged about the approach we took here, was we were able to increase the female heart disease detection by like 6 to 8% across this data set, and actually improve the overall detection in the data set by 2 to 3%. So it was an incredible, win and a really neat example, and one that is early, but I think has a really potential to impact anywhere from medical disease data sets to voter data to all these areas where you're seeking to boost an underrepresented or minority class in your data.
I'm sure you always have to worry about new biases, of course. That's the challenge that we find ourselves in with machine learning and AI. But you're saying you're actually, in this case, your heart disease example, you're countering bias in some case because you're better representing the female community that was 2-to-1 in the original data set.
Yes. It's a case where there's no substitute for having equal, numbers of patients and patient medical data inside these data sets, but it's either cost prohibitive for you to gather more data, which or just impossible to replicate the same process that was used to gather that data in the first place. So, we've seen across most applications of machine learning we talk to, whether, I think it's been really popularized in the, kind of face detection space where different skin colors or shades or things like that of people's skin drastically affect the ability of that facial recognition software to work. It may be impossible to gather, that purely uniform set. So what if you can use a technology like synthetic data to help these algorithms generalize better and perform better across all these different types of classes in the data?
You mentioned that this is an open source synthetic data library. So where's the sweet spot for Gretel? I mean, where's the business plan?
We felt that open source was really important with our customer sets being developers. First, it's important. A lot of developers need to know how things work. We also believe it's too important to get this wrong, right? Creating a black box technique saying, give us your data set and we'll give you something back that's going to correct bias or introduce privacy, guarantees. It's like encryption in that case, right? It's too important to get wrong. So we started off early with an open source approach that allowed us to get a lot of feedback as well as auditing from the community, which I think was really cool. The business model for Gretel is around helping companies do this at scale. So how do you go from a really cool library that you can use to create artificial data sets to operationalizing that inside your environment? As you were saying, so many customers, they want to run on premises in a hybrid environment. They want to run inside their cloud. So how do we make it simple for them to deploy and integrate this into their data engineering workflow? That's really where our business model is. We launch a set of APIs, very similar to how you would pay for cloud compute. Our business model is based on charging for the amount of compute that we do building synthetic data on behalf of the customer.
Presume you have tools now that sit on top of the library that are they industry based? Are they use case based?
Yeah, these tools we've built APIs to simplify certain use cases. I want to build a private version of this data set, so it'll train a synthetic model using differential privacy, or I want to boost this minority class. These tools get deployed. Either we'll run them on a customer's behalf inside the Gretel cloud, so you can simply just call our SaaS APIs and say synthesize this data set, or you can deploy inside your own environment. So we're aligning once again with really kind of best of breed technologies. We had a lot of customers that build with Kubernetes and containers, and that's how they're doing data engineering. That's how they're enabling kind of scalable workloads within their environments. So we enable you to deploy our APIs as a container inside your environment, and you can call it just like you would call our cloud service.
So when does synthetic data, is it not sufficient? Does it not work? Where you'd say, hey, I wouldn't use it in this case.
Data that you need to be able to tie back to an actual human entity, then I think that's really important. So let me give you an example where you are a team that's investigating fraud across your international business. You need to be able to tie that back to actual accounts. So when you're doing that investigation process, it needs to tie to a real person. In that case, synthetic data may not be the right answer for you. You may use synthetic data to train your models to detect this, but at the same time, you need to be able to find that actual entry in your database, that actual user that might be causing fraudulent activity. So in those cases where you need to link back to a real entity, a real human, anything like that, in that case, you wouldn't want to use synthetic data. So when companies are sharing data outside of their walls, synthetic data is at a point right now that it's hard to see an example where it wouldn't be better to share the synthetic data example when you don't want things to be tied back to a customer than to share the raw records that have been de-identified, because we see all these attacks emerging where these data can be re-identified, which creates a lot of risk for your business. So that small kind of hit you might take on utility, I think, somewhat, I'll admit, somewhat biased perspective here, but when it comes to protecting your brand and your identity as a business and the trust you have with your customers, I think synthetic data is at that point now where you can really start thinking about, should I be sharing raw records to business partners, to third parties, to the different the data consumers that I have the partnership agreements with, or should I be sharing synthetic data? I really think we're at a point now you can start looking at synthetic data and start thinking about how you would use that at scale.
Is healthcare, is that the industry at the top of the list?
Sparked by the pandemic, we have seen such a just incredible, and I think it kind of inspires confidence in humanity, interest in sharing these data sets that historically would have been really difficult to share. So that's been great. We see a lot in the financial space as well, working with sensitive data, wanting to enable innovation on behalf of customers. A fun sector that I would like to kind of call out here actually is we've had surprisingly really neat use cases emerge out of the gaming industry.
The gaming industry. You got to tell me more about that. So give me a use case there.
As it turns out, games gather tons of information, and particularly if you start looking at like AR and VR or the mobile application games that we're playing, incredibly personal information and about how gamers are playing their games, what features do they like, things like that. The game companies we've talked to, I'd say there's two core use cases. One, they want to enable an innovation on behalf of their customers, but like in a really privacy preserving and fair way. So how do we learn about the game without learning about the gamer is a really big use case. The second one, I would say, and I think it's kind of interesting in the gaming world, you want to create the most inclusive environment possible. You want to create an environment when you're playing games that encourages anybody from any background to come join. That may not be the way that things are today. So the question is, how do we learn from our data in a way that doesn't amplify existing biases in the data, if that makes sense? So how do we create really that kind of fair world? And one of the gaming machine learning leads that we talked to actually, phrased it really well. He was saying that in the virtual world, if anything, the biases that we feel in the real world are amplified, and that would be reflected in our data. So how do we remove that, and how do we create like kind of really the kind of even playing field and that kind of fair and inclusive experience?
I wanted you to define practical privacy before we finish here. What's practical? How does that differ from impractical privacy?
That's one we've been thinking about and really working on with our customers. We started out trying to say, how do we crack this nut of giving you guaranteed levels of privacy for your data? And this is an area that has been an active research topic for the past 20 years. If you've heard of differential privacy, that's an example. And I think that's the most kind of like hardy and probably well-studied version of privacy, where you can give actual mathematical guarantees that an individual user's data won't be replayed or compromised by your data set. The challenge that you see there is, while differential privacy is really easy to say, understanding those guarantees is incredibly difficult. You get these two values, one's called epsilon, one's called delta, and those values are anywhere between 0 and 1,000,000, and you need to translate that into what are the actual guarantees and privacy I get. And if you're not a data scientist who has a background in privacy, it just doesn't make sense. So our question is saying, how do we take a combination of those theoretical guarantees we can give that give you hard, mathematically backed protections against the types of data attacks we know about, and how do we turn that into something that you can reason about for your own use case? As you introduce more privacy, you're going to have, in many cases, a hit to your accuracy. And how do you find that right balance? And how do we describe that in a way that makes sense to a developer, it makes sense to a product manager, or someone like that's making a decision about how their data is going to be used?
Is there such a thing as guaranteed?
Differential privacy, and this is a whole podcast on itself, does offer, in certain cases, guaranteed in the terms of resistant to any known or future attacks on data, protections against data. But that comes at a real hit to accuracy. So the 30-second, kind of version of differential privacy is that if you have a data set of, let's say, 10,000 users, and you have a single user that lives in the state of Washington, right? If you were to do a query across that data set, you could compromise that user's identity. Differential privacy works by inserting enough noise into that data set using it's called a Laplacian distribution, but insert enough noise into that data set that user in Seattle, their identity would be protected. That noise comes at a hit to accuracy. So while that is possible in many cases, the compromise you have to make requires a really large data set. The areas where I've seen differential privacy actually applied, working successfully, U.S. Census Bureau uses that for all the statistics that they release about U.S. Census data. You also see Apple and Google using differential privacy for when you're predicting what emoticon, it's suggesting what emoticon for you to use next when you're typing a text message. That is actually based on differential privacy training in the background, but it requires tremendously large data sets. So it is possible. How do we make that more accessible, and how do we make it more understandable so you can really kind of understand that trade-off is a real kind of ongoing research topic and challenge.
Please keep us posted on your progress. I know the listeners, as well as I, would like to see how it goes and where you are, say, for example, in a month's time, 2 months' time, and we'll post on it. Where can folks reach you and Gretel?
So if you just go to the website, Gretel.ai, you'll see contact information. We have a Slack channel that enables any person with any questions to reach out to me directly or to ping any of our developers. And I will also share my Twitter handle with you.
That's great. Do that. We'll put it in the show notes. What do you do for fun?
I have 3 daughters. I've enjoyed recently, we've gotten back into rock climbing now that things have started opening back up. So there's some cool gyms near our house. That's a ton of fun. Kids are pretty into reading, so we do that as well. Looking forward to a little more normalcy coming back.
How old are your daughters, if I could ask?
I have twins that are 11, going into middle school next year, and then my youngest is 9.
Very nice. Mine are a little bit older than that, but I can tell you, you're a lucky man to have daughters. I have to say that. I won't say this too loud so that I don't get a big head, but you're a lucky man to have daughters, I have to say. Good for you, man. Pleasure talking with you. Look, when you start these podcasts, it's kind of like, what are we going to talk about today? And then once you get into it, we didn't even hit the surface of practical privacy. There's so many things we could keep going on. This is fantastic. I learned a lot.
I love it. Thanks, Alan. It's really gotten, I think really interesting topic to think about is that intersection of privacy and security and how those two fit together. So definitely enjoy the conversation as well.
Well, great. And I'll look forward to following your progress. I want to stay in touch. Thank you so much. Fantastic. Appreciate you being here. Listeners, as always, I want to thank you. And I'll repeat, as I always do, please reach out to us at almartintalksdata@gmail.com. Like to hear from you. Like to hear of any guests that you have. That's how we receive our guests, like our good man Alex here. We find interest from the listeners themselves. So please reach out. Please rate us on your favorite location of where you hear the podcast. And we'll talk to you next time. I'll see you on the podcast. Later, guys.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcast to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests, and do not necessarily represent the views of IBM. Until next time, let's go. Over and out.